Hey, it's Random Code here, and today we're going to look at day 2 of Advent of Code, Cube Conundrum, where it is a bit easier, I think at least, than day 1, but it's still interesting, a small problem, and we have 2 parts as usual. And where the first part we need to determine if a game is valid or not, where we have some kind of rules. For example, we can only have 12 red cubes, 13 green, and 14 blue cubes. We then have sets of drawing of these cubes from the game. So for example, we can see that in draw 1, 3 blue were drawn and 4 red. So that's valid because 3 blue and 4 red is not above any of the constraints. And then we have a draw of 1 red, 2 green, 6 blue, valid, and 2 green, valid. And it's worth noting that each time the cubes have been drawn, they're then put back into the draw pool. So we do not even need to add them together, we just need to check actually if any of these values is above their constraint. So for example, in game 3, we have that we draw at some point 20 red cubes, which is above our constraint, so game 3 is an invalid game. And we then simply need to check all of them if they're valid, and we then need to sum up the game value or the game number for all the valid ones, and we then get a result, in my case 2285, which was my correct result. And then how we do it is, once again, we have this large game file, input file with, in this case, 20 games, not 20 games, 100 games. I then very simply have created first a map containing my rules, so my max cube colors, 12 for red, 13 for green, and 14 for blue. And then have a small Boolean is record valid checker that simply checks if a record is valid. And then in a find result method, we then simply go through all our records from our input data file. I use a Java filter, it's valid, keep it, and then I simply just extract the game number and add them together. So relatively simple, but how we then actually check if a record is valid is that I am using Java splitting on strings. We could probably use some kind of regex as well, but I thought this would be, I don't know, a fun little way of doing it. So first, let's actually just bring this up here so we can have a look at it. This is our record. So we have game 1, colon, then all our data, all our draws are then separated by semicolon, and each of the draws are then separated by comma. First, I would take the string, separated by semicolon, or not semicolon, colon at first. I would then take the first parameter in this list, meaning this part of the record. I would then split it on semicolon, and I will end up having a list of this element, this element, and this element. I would then run through each of them. In this case, I'm just using the stream, and an all match, meaning I would for each of them return a boolean if this part is valid, and if any of the parts are false, then our entire record valid is going to be false. When then going through all our draws, we then simply first split on comma to have our individual drawings. Our individual drawings then are being trimmed, so removing any empty spaces on the right or left of the string. And then split on empty space, meaning we would now only have 3 empty space blue, for example. We then have this cube data part containing 3 as the first element, which I then extract into an int amount. And my value blue I insert into a string color. I then very simply just extract from my max map and get my max amount for this given color, and then simply return for this specific drawing if my amount is less than or equal to the max amount. And this is more or less then just simply checked on each drawing, and we do not actually care too much about them being in different drawing pools and everything, because we, at least in this part, assert or assume that, for example, we cannot draw blue more than once for each drawing. And that's actually more or less it. Just a lot of splitting. Could be a bit confusing, but it's actually not that hard when you just go through it step by step. Splitting, splitting, splitting. We end up having 3 blue. Split once again, we have 3 and we have blue, which is 3 for blue less than 14. It is, so true. And then our all match just assumes that if all of them are true, we return true for the record. If the record is then true, we keep it in the list. We then again use some splitting to now actually get our first part of our split from our colon. And we then have our game colon the number of the game. We split again on empty space, and we then take the first element. and that's going to be a game number, and then we simply just sum all of these game numbers for all the records that actually were valid. And we can run it, but it doesn't show too much other than we print that result of day part 1 is, in my case, 2,285. And if we then look at day 2, part 2, it's again using the same data set. But now we need to find the min size of the pool based on the game input. Meaning we simply need to find what is the largest blue value defined in this game, largest red value defined in this game, and largest green value defined in this game. So it's actually just very similar to the first thing. We are splitting. We end up having a look at, let's actually bring over my example of the record. But once again, we end up having blue, and then keep track of the max red, max blue, max green. So when we there once again end up looking at 3 blue, I would simply set my max blue to be equal to either the max value of the last found blue, in this case going to be 0, so we're going to take the max of 0, comma 3. The max is going to be 3, so our max blue is now going to be set to 3. And then just go through all of them, and in this case, let's say we found a 1 blue, then going to be comparing is 1 or 3, which value is the largest. 3 is going to be the largest, keep max blue as 3. And then in the end, I very simply just return max red multiplied by max blue multiplied by max green, because that's the requirements for the task. And we then now find result very simply, run through all our records, find these max values multiplied together, and then reduce it to a single value by summing them together. And once again, we can run it. That's not too much to see, as again, just get a very large number, 77,000. And that was, for my case, the correct value. So that was very much the day 2 of Advent of Code, where day 1 were a bit more focused on interacting with a small string, binding elements into string. Day 2 was very much focused on being able to separate a large amount of input data and then extract the different parts. This is kind of interesting, but at least in my experience in larger real-world applications, we would not do this too often, as data would either already be structured in some kind of database, or we might have some kind of JSON, and then we would often just use some kind of JSON library that would actually split and sort our data. But as mentioned, there'll be multiple ways of doing this. I'm doing like a pretty straightforward of just splitting, and then in this case, getting the max value, or here just very simply checking if a value is smaller or larger than the max value. Otherwise, if you enjoyed this video, please leave a like and subscribe, and wish you all a wonderful day.